In this experiment, I'm trying to use a TI PMLK, Texas Instrument Power Management Lab Kit, in association with Worth Electronics to use and anticipate conducted emissions on a DC line. The demo keys are actually run by, I'm currently using at a 5 volt input and 3.3 volt output. It is a quite nice, very jam-packed design kit, ideally for educational and deep divers. So let's not go into more detail because it has got a current mode controller on the bottom side, voltage mode controller on the top side. That's LM3475 voltage mode controller on the top side. Now connect your power supply to the north. Come on. And then via smart fuse, current sense transformer, 1-to-1 transconductance. You got L and C, which is part of the LC filter, output, power inductor, and the same goes on the output side. Okay, jumper, by setting jumper in, you are bypassing L, part of the LC filter. It means when you have a jumper in, the noise should be higher. Take the jumper out, means the filter is now kicking in, and that should block all the high frequency going back to the power line. How can I prove it, and what's the impact of LC filter at high frequency? Here we go. So I'm currently, let me put camera on as well. Currently running at 200 kilohertz. Filter is in. You can see there is no jumper, and I can see my attenuation is quite perfectly working good. Noise distribution is evenly across the entire spectrum, and everything is running soft. I may be able to change the frequency, and you can see the shift. So currently we run at 100 kilohertz. Okay, so some peaks are coming up. Let's clear off the white noise. Now let's insert a jumper. It means bypass the L of LC filter. It may turn off, but it's better to turn off first and then turn on. So the DC-DC converter is restarted. There is no L now because I have inserted a jumper across that. All what you have is just a C. And because of the C, I can see the peaks coming up here. There are top 5 measurements I have actually added. And you can see at 100 kilohertz, 200, 300, 400, and so on. The histogram is now kicking in. You can see the energy is not being distributed equally, but it's picking up at a switching frequency and its harmonics. Let's increase the frequency all the way to the max. Currently 270 kilo, and you can see the peaks are also appearing equally. Clear the max hold, start again, and top 5 peaks are also exactly the multiple of my switching frequency, 270K, and so on. How do you now improve it? How can I design LC filter? Is there a formula available? Is there a simulations available? Which we're going to discuss into the next half an hour or so, using another video most likely.